Okay, hello, welcome back to another section in further maths. In this section, we'll be continuing our solvings and explanation of the trapezoidal rule, just like what we did in our last lesson. But before we move further, I would like us to get a big review of what we talked about in our previous lesson on trapezoidal rule. Okay, welcome back. Now, with what we just saw, or what you're seeing right now in front of you, you discover that there's a question that says find the approximate value of 3 bounded by 1 the x over x at an interval of 0.1. You can still remember the trapezoidal rule that we stated. Let me just put it down here as a form of reminder. We have to use it in solving this. The x equals to 1 over 2h bracket y1 plus yn plus 2. So we now have y2 plus y3 plus y4 to get to yn. Now this is the formula that we'll be applying into solving this question. Now with what we have here, remember how it's being stated, we have our x value and we have to generate the y that has to do with the inverse of this. So first of all, we have the boundaries 3 and 1, then dx over x. This is equivalent to 3 and 1 1 over x dx, which is equal to 3 1 ln s. So if you should integrate this, you have this, but for the sake of this, we are not expected to integrate it for now, so we just leave it at this format, and it serves our y now takes the value of 1 over x. So let's bring our values down, x, and this is our y, which is 1 over x. So if this is 1.5, interval of 0.5, this should be 2.0, 2.5, 3.0 continuously. And at this point, we have 1 over x to be in 1 over 1 is 1. 1 divided by 1.5 is 0.67. 1 divided by 2 is 0.5. 1 divided by 2.5 is 0.4. And 1 divided by 3 is 0.33 approximately. Now in solving this, let's apply our rule. Applying the rule, you see that we'll be having our fx dx will now be equals, the first is 1 over 2 here, h, which is also 1 over 2. Then you open our bracket, our y1 plus this, that is the next, which is 1 plus 0.33, which happens to be the last value, plus 2. We are making use of the formula we stated at the top here. Then the next thing is 0.67. 0.67 plus the next value 0.5. 0.5 plus our next value 0.4. 0.4. You're just applying this 0.4. We're stopping here. So this becomes, this plus this is 1 over 4. This times this is 1 over 4, and this is 1.33 plus, remember there's a big bracket, plus 2 in bracket 1.57. So this is now equivalent to 1 over 4. This times this will give you 4.44. So our final answer becomes 1.12. So find the approximate value of this at this interval of this is equal to 1.12. That's the value. Now we can also apply, because we've been dealing in the spirit of application of integration, application of integration We've seen how we can apply it in looking for areas of bounded shapes, unbounded shape. It can be applied into kinematics. And kinematics talks about considering a body in motion and talking about the force that causes the motion. Now, when you're talking about the force that causes the motion, that's you have to consider the velocity, acceleration, time, distance, and the velocity. You can also talk about initial and final velocity. So these are the points to consider when you're talking about kinematics. When you're talking about kinematics, these are the parameters that we're going to consider. Now, if the velocity is given as a function of time, the displacement or distance is the integral of velocity function with respect to time. So if we have this as a velocity, the distance over time will be this. Then the distance itself is the integral of time plus c. So similarly, if the acceleration is a function of time, velocity is the integral of acceleration function with respect to time. Now, can we just try one question before we wrap up the area of application of integration? So we have application of integration, application, integration, application. Let's solve the question that is right in front of us. Now, this question says, we start picking our terms gradually. The question says a particle is projected in a straight line, okay, from O until a speed of 6 meters is attained. Okay, at time t seconds later, its acceleration is this. So remember, acceleration is equal to change in velocity all over change in time. So dv dt is 1 plus 2t. That's what was given to us. So with this, before we continue reading, let's get our value of v. Remember, your v will now be the integral of this. So integral of this with respect to t will now be equal to t plus 2t squared over 2 plus c, which is equal to t plus, this goes with this, t squared plus c. So our value for v, velocity, is this. So if this is velocity, now we can still use this to also get our distance, but let's move further before then. Now, at this, calculate the particle's velocity and its distance from O. Now, after getting this point, they said it moves from where? 0 until the speed is this, it's attained at a time t second. So when t is 0, when t is equal to 0, you discover that if you put t as 0 here, the value of your v is equal to your c, and v is equal to 6 meters at that point, because it was stated it's until this is attained. So that is to say our c is equal to 6. So let's go into writing the equation. So the value of our v becomes t plus t squared plus 6. But we are interested in also getting the value of our v. So but when t is equal to 4, when t is equal to 4, let's get our value of v now. Our v is equal to 4 plus 4 square is 16 plus 6, so it's equal to 26 meters per second. That's for v. Now let's do the velocity and its distance. Distance is x, but remember that v is equal to dx over dt, that distance over time. So therefore our x will be the integral of this, of our v. So the integral of v is t squared over 2 plus t3 over 3 plus 6t plus a constant. But at this point, since we've gotten the constant, okay, the constant is c. So since we've gotten the constant, it's no longer needed. in our analysis. Let's integrate this. Okay, this is the integral of this. Integral of x is this. Now let's substitute t as 4. T equal to 4 at this point. We now have 4 raised to power 2 over 2 plus 4 raised to power 3 over 3 plus 6 times 4. So we are now having 16 over 2 plus 64 over 3 plus 24, which will give us 160 over 3 distance meters. So the final value of distance at this point when t is 4 seconds is equal to 160 over 30 meter. You can go further into breaking this from fraction, and you'll be having an approximate value of about 53 point something, about 53.333 meters thereabout. So I would like to say a very big thank you for joining us in this lesson. But to refresh your memory on what we've just discussed, please take the test that will appear on your screen. Do well to use this lesson notes on this platform for better information on the topic we've discussed. Thank you. I would like to see you in our next lesson.